So, when you look at an integration problem, what's the big key that tells you I'm going to use partial fractions on that one? You'll have a fraction, and the bottom you can factor. Those are the two things you're looking for. So we might have the integral of 3 minus x divided by 3x squared minus 2x minus 1 dx. So there's a fraction. The first thing I would still try is I would still try to use u substitution. Can I use u substitution? I'm going to use u substitution. What would u be? The bottom. So if u is the bottom, I take the derivative out. I'm going to get 6x minus 2. Can I get a 6x minus 2 out of my top?
If you really mess with the fractions, maybe.
No, I don't think so, because the fractions here are in a ratio of 1 to 3. And this would be 6x minus 2, which would be in a ratio of 3 to 1. So I don't think I can mess with my fractions and make it work. So, again, I look for u substitution, because that's always the easiest way. I don't think it works. So then the next thing I would have to ask myself is, can I factor the bottom? Yes. Okay, so if I can factor the bottom, I can use partial fractions. How does the bottom factor? Well, it's got to be a 3x and an x, right? And then the only way to get the number 1 on the other end is 1 and 1. Can we make our signs work out to get the right answer? 3x plus 1 and x minus 1, because that would give us a negative 3x and a positive 1x. That would give the negative 2x in the middle. So that works out. And so we were able to factor our bottom. So we're able to do a partial fraction decomposition. That means we're going to have some number a over 3x plus 1 plus some number b over x minus 1. Then what do we do? You multiply the whole thing by the common denominator, 3x plus 1 times x minus 1. Left-hand side, 3 minus x. Right-hand side, a times x minus 1 plus b times 3x plus 1. The book then went through a process of multiplying the a and the b through, coming up with a system of equations, solving a system of equations, but I showed you a shortcut. What was the shortcut? Pick a number that you like. And which number do you like? 1. You definitely like the number 1, because when you plug 1 in, it makes this part equal 0. So you plug 1 in, you have 3 minus 1, that's 2, equals b times 4. So b is a half. And then you repeat. You plug in another number you like a lot. What's the other number you like a lot? Negative 1/3, because negative 1/3 will give you 0 over here. 3 minus negative 1/3, that's 3 plus 1/3, that's 10/3, equals a times negative 1/3 minus 1 is negative 4/3, which means a is, I flip and multiply, 5 halves. Negative 5 halves. Got my minus sign there. Negative 5 halves. All right, so we've done all the algebra we need to do. Now we go back and do our calculus. This becomes the integral of negative 5 halves over 3x plus 1 plus 1/2 over x minus 1 dx. I integrate. I'm going to have negative 5 halves times. What's the integral of 1 over 3x plus 1? ln of 3x plus 1, that's almost correct. Not times 3. Over 3. Why over 3? Yeah, it's really a u substitution problem. You'd really have to let u be 3x plus 1. So du is 3 dx. So it's one of those deals where you'd have to slip a 3 in here, which means you'd have to slip in a 1/3 to balance it out. So you're going to get a 1/3 ln 3x plus 1 plus 1/2. What's the integral of 1 over x minus 1? ln of x minus 1, because the u substitution works out perfectly there. U is x minus 1, du is dx. Plus c. All right, so that's kind of where we left off when last we met. We were doing problems like that, problems that factored, bottoms were linear. All right, what about, find some hard ones here. Oh boy. The integral. X squared plus 12x plus 12 divided by x squared minus 4x dx. How is this one different? We got stuff up on top. It's stuff up on top of the other one, though.
Both the top and bottom are in factor.
No. You could factor the bottom. I don't think the top factors. But there is a problem. What's the problem?
There's 3 terms on top and 2 on bottom.
True. You're getting close. I could put 3 on bottom. You just don't write that one. But you're getting very close. Same powers. What do we have to do when the power of the top and the bottom are the same, or if the power of the top is bigger than the power of the bottom?
Divide.
We've got to divide it first. So that's something to watch out for. Sometimes you have to do a long division. Okay, so we got to come here and we got to divide. We got to take x squared plus 12x plus 12 and divide it by x squared minus 4x plus 0. What do I write? What goes here? 1. Because 1 times x squared is x squared. We're going to have x squared minus 4x plus 0. We subtract, carefully watching our negative signs, and we end up with 16x plus 12. All right, and that's all the division we have to do, because now this 16x plus 12 has a smaller power than the x squared minus 4x. Our integral becomes 1 plus 6x plus 12 over x squared minus 4x dx. All right, so watch out for those. If the power on top is bigger, or if the power on top is the same as the power on bottom, you first have to divide. I can integrate 1. What do I get when I integrate 1? X. That part's easy. What about that?
Is that 16 or 6?
It should have been 16. It was 6, but it should have been 16. How do you integrate that one? I could complete the square, but that would be harder. Does the bottom factor? Yeah, you can take out an x. It factors as x times x minus 4. So since the bottom factors, we can use partial fractions. Partial fractions is in my opinion, easier than completing the square technique. Okay, so I'm going to have, leave some space here, do my partial fraction work down here maybe. 16x plus 12 divided by x times x minus 4. So what are my two fractions going to look like?
A over x plus b over x minus 4.
A over x plus b over x minus 4. Those are the two pieces that I have. Clear the fractions. 16x plus 12 equals a times x minus 4 plus bx. Same exact trick. I plug my favorite numbers in. What are my favorite numbers this time? 0 and 4. When x is 0, I get 12 equals negative 4a, which tells me a is negative 3. And here, when x is 4, I get 16 times 4, that's 64. 64 plus 12, 76, equals 4b. So b is 76 divided by 4 is about 19. Yes? Equals 19. What's that?
Beast mode.
Stood in here. Beast mode? Oh,
Beast mode.
with my division?
Yeah.
When you teach for as long as I have, your arithmetic gets really good because it takes too long to get your calculator out. 25 years of practice, you know. All right, so anyway, this is the integral of 1 plus negative 3 over x plus 19 over x minus 4. And I integrate. The integral of 1 x minus 3 ln x plus 19 ln x minus 4 plus c. Questions on that one? All right. But notice this one eventually it factored. When it factored, we still had just two distinct linear terms. So we really haven't done anything new yet. So now let's try one where that doesn't happen. How about the integral of x squared minus 1 over x cubed plus x dx. Once again, you might try u substitution. I think you would find u substitution doesn't work. Next question is, can I factor the bottom? Yes, I can factor out a x, so that tells me I can use partial fractions. So I'm going to have x squared minus 1 over x times x squared plus 1. And here's where things are different. With just the x here, that's nothing new, that's a linear. So that's going to be a over x plus, here's the new thing. The second fraction has x squared plus 1 on bottom. That's a quadratic, x squared, that doesn't factor. When you have a quadratic on bottom that doesn't factor, what you need up on top is a linear. So here when I have a linear on bottom, I have just number on top. When I have quadratic on bottom, I need linear up here. So what am I going to write for a linear?
Bx
Bx
plus 1
plus c. We don't know that the c is the number 1. So we have to write the function, a linear function. So we're going to have a bx plus c. So notice the big change there. When you have a quadratic on bottom, linear on top, which means now we have 1, 2, 3 variables that we have to deal with. Seems like it just got harder, right? Yep, I did. Not going to lie to you. Clear your fractions. Multiply by your common denominator. X squared minus 1 equals a times x squared plus 1 plus bx plus c times x. All right, Tom. Again, if you read the book's going to say multiply this x through, combine all your like terms, and then write a system of equations, 3 equations with 3 variables. How much fun is it to solve 3 equations with 3 variables? Zero fun. Unless you know how to do it on your calculator, then it's not too bad. Use the matrix method on your calculator. We're going to use a shortcut. I'm going to pick my favorite number. Why is 0 your favorite number? Not only does it get rid of b, but when I plug 0 there, it also gets rid of c. It gets rid of 2 of them, doesn't it? So I'm going to plug in x equals 0. I get negative 1 equals a. Because when I plug 0 in there, 0 plus 1 is 1. Plug 0 in there, 0 times that whole thing is 0. So a is negative 1. Then I'm going to plug in my next favorite number. What's my next favorite number?
0.
I can't use 0 again. I do like 0 a lot, but I can't use it twice. My next favorite number is I. Why I? It cancels out the a, doesn't it? Because when I plug I in there, I'm going to get negative 1 plus 1. That's 0. That makes the a go away. Let's see how much that helps, though. So when I plug in I, what's I squared? I squared is negative 1, so negative 1 minus 1 is negative 2 equals, over here I get bi plus c times I. Multiply the I in. So that becomes negative b plus ci. No, I got to distribute. So I took the I times the bi. That gave me the negative b. And then I got to take the I times the c. Does that help? Well, look what happens here. I end up with a complex number over here, don't I? What do I have over here? Which is a real number. So what has to happen is the real part of the number over here has to equal the real part of the number over there, and the complex part over here has to equal the complex part over there. So negative b has to equal negative 2. Those are the real parts. So negative b has to equal negative 2, which tells me b equals 2. Over here, the complex part is ci. What's the complex part over here? 0. So ci has to be 0, which tells you c has to be 0. So it does help. It does allow us to completely solve that system of equations by only plugging in 2 numbers. And that's a trick I've never seen in any textbook anywhere. That's a George Herbert original right there. Plug in complex numbers.
Isn't that like the standard form for like, I remember learning like algebra 2 where...
The standard form for a complex number is a plus bi. That's correct. Where we call the a the real part and the b the imaginary part. All right. So all the algebra's done. We come back here. We're going to integrate. We're going to have A was the number -1, so we're going to have -1 over x plus 2x, because b was 2x over x squared plus 1 dx. This is, what's the integral of -1 over x? Negative ln x. Plus, what's the integral of 2x over x squared plus 1? You're close. It's just ln of x squared plus 1. Because you would let u equal x squared plus 1, du would be exactly the 2x dx. It works out perfectly. It's a perfect u substitution. You don't have to mess with any numbers. Questions on that?
But the C, C was 0. It's ABC, right? Not the constant.
It's ABC, 3 numbers that has nothing to do with plus C. Yeah. This C has absolutely nothing to do with that plus C up there. Let's call this C sub 0 to indicate that they are different values. Yeah, this C and that C are different. Yes. Other questions on that? All right, let's see what else we have in here. Integral of 6x over x cubed minus 8 dx. Can you use u substitution? No, unfortunately. If this were a 6x squared, then we could use u substitution. Or if that was x squared minus 8, I could use u substitution, but unfortunately I cannot use u substitution. Can you factor the bottom? Can you factor x cubed minus 8? Yes. Otherwise it wouldn't be in this section on integration by partial fractions. So then the big question is, how do you factor x cubed minus 8? Good guess. Correct, but not completely correct.
X minus 2 cubed.
No, it's not x minus 2 cubed. All right, so remember, if you had x minus 2 cubed, that would be x minus 2, x minus 2, x minus 2. And when you do FOIL, you're going to get a whole bunch of middle terms. And then you've got to multiply again. You're going to get some more middle terms. This would turn out to be x cubed minus 2x squared, 6x squared, plus 12x minus 8, I believe, if you FOIL it all out. Doesn't work. All right, so this is a formula that I know you saw somewhere back in algebra that you never had a use for until now. There's a formula for having something cubed minus something cubed. 8 happens to be 2 cubed, doesn't it? 2 times 2 times 2. The formula for a cubed minus b cubed is a minus b times a squared plus ab plus b squared. That's how that factors. If you don't believe me, come over here to the right-hand side, distribute, combine all your like terms, and you will get that back. And just in case you need it, there's one that looks the same except it's got a plus in the middle. That one's a plus b, a squared minus ab plus b squared. So we're going to use this formula where a is x and b is the number 2. So this is going to factor as x minus 2 times x squared plus 2x plus 4. And you can try it. Unfortunately, x squared plus 2x plus 4 does not factor. So you're left with a quadratic here that does not factor, what we call an irreducible quadratic. We're going to have a over x minus 2 plus the second one, again, that one's quadratic. Since it's quadratic, we need linear up on top, bx plus c. Clear the fractions. Six x equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Again, I plug in my favorite number. My favorite number is x equals 2. Why do I like x equals 2? It gives a 0 over here, which knocks out both the b and the c. 12 equals a times, plug in 2, I'm going to have 4 plus 4 plus 4, that's 12. A equals 1. What's my next favorite number to plug in? Well, what would I like to have happen? I'd like to plug in a number to make this be 0. What number do I plug in to make that equal 0? And not so easy, is it? It doesn't factor. So how would you have to solve this? You could complete the square. That would be the hard way. What's the easy way? Do what? Kind of equation? What kind of function is that? Quadratic. How do you solve quadratic equations? You use the quadratic formula, don't you? All right. So you use the quadratic formula. I happen to have a nice program that does quadratic formula for me. Program, quadratic formula. A is 1, B is 2, C is 4. I don't get very nice numbers. I'm not really sure that I want to plug in negative 2 plus and minus square root of 12i over 2. That's not that bad. So my next favorite number is x equals negative 2 plus or minus square root of 12i over 2. But before I plug it in, I'm going to reduce it. What can I do with the square root of 12? That's 2 root 3. And once I write that as 2 root 3, I've got a 2 there, I've got a 2 there, and I've got a 2 there. So it's negative 1 plus or minus root 3 I. Now I only got to pick one of them. Do I want to use the one with the plus or the one with the minus? The plus. All right, so I plug it into the left-hand side, and this is going to get a little complicated. We're going to have 6 times negative 1 plus square root of 3i equals, this whole part is 0. That's the whole reason for picking this pretty ugly number. We're going to have b times negative 1 plus square root of 3i plus c, and then all that is multiplied by negative 1 plus square root of 3i. Say that again?
Minus 2 on the last part.
Oh, rats, minus 2.
So say versus that, it's divided over. What?
All right, so it may have been easier to set up the system of equations for this one. I'm not sure yet. What I am sure of is I'm going to need more room, so I'm going to come down here. That's negative 6 plus 6 square root of 3i equals. All right, now I have to take this number here, this negative 1 plus square root of 3i minus 2, and multiply it by that number, don't I? All right, so that's going to be, leave myself some space here, negative 1 plus square root of 3i times negative 1 minus 2 is negative 3 plus square root of 3i. And I multiply, that's 3 minus square root of 3i minus 3 square root of 3i plus square root of 3 times square root of 3 is 3, then I times I is I squared, which is negative 1, so this is going to be a negative 3, isn't it? Hey, that turned out pretty good. That's negative 4 square root of 3i. So that gets multiplied by the b number, doesn't it? That's negative 4 square root of 3ib plus, now this gets multiplied by the c number, so I'm going to have negative 3c, negative 3c plus c square root of 3i. What's that?
So I think we went down a dark path.
I did go down the dark path, but I'm about to see the light. And it's not the train coming either. Because look what has to happen now. The real parts on the left has to equal the real part on the right. What's the real part on the right? Negative 3c. So c has to be the number 2. And then the complex part on the left has to equal the complex part on the right. But now that I know c equals 2, I can plug 2 in right there. So I end up with 6 square roots of 3 has to equal negative 4 square roots of 3b plus 2 square roots of 3. I drop the i's because they all have i's in them, don't they? There's an I there, an I there, and an I there, so I can drop the i's. The complex part has to equal the complex part. Subtract that 2 square root of 3 over, then divide by negative 4 square root of 3. B equals negative 1, because of that minus sign right there. B equals negative 1. Okay, so that one was certainly by far the hardest one we've done. And we're not done yet. All we've done so far is the algebra. Now we got to go back and play calculus. All right, so we come way back up here. We're going to have the integral of a. I found a so long ago I forgot what it was. A was 1. 1 over x minus 2. Plus bx plus c, where b was negative 1 and c was 2. So negative x plus 2 over x squared plus 2x plus 4.
We have to do another one for that side.
Well, let's do this one first.
Okay.
Start with the easy one. ln of x minus 2. Now what? U sub. I would love to use U sub. U is x squared plus 2x plus 4. So du is 2x plus 2 dx. I need a 2x plus 2 up there. I have a negative x plus 2. So what? Didn't work, did it?
That's heartbreaking.
Heartbreaking.
We're still in that part.
Any clever ideas? I can't do it again because the bottom doesn't factor. So I can't do partial fractions again. I think I'm going to eventually have to complete the square. Is it? Oh, absolutely, it's worth it. What if? I really wish I had an x plus 1 on top, because even an x plus 1 would work, wouldn't it? Right? So I'm going to rewrite this top. I'm going to rewrite this as negative x minus 1 plus 2 plus 1. So what did I do on the top?
Added 0.
I added 0. And then I'm going to have the x squared plus 2x plus 4 down on bottom.
But you added 0.
I added 0. I did a negative 1 and a positive 1, didn't I?
You did nothing.
I did nothing. I wrote 0 in a funny way. All right. ln of x minus 2 plus integral negative x minus 1 over x squared plus 2x plus 4 dx plus integral 3 over x squared plus 2x plus 4 dx. That's sneaky, because now for this integral, U substitution will work, won't it? Because I get the x plus 1. I need a 2, so I need to sneak in a 1/2, and then of course I need to factor out that minus sign also, don't I? Okay, so we're almost there. We have ln of x minus 2 minus 1/2, because of this 1/2 and those minus signs, ln of x squared plus 2x plus 4, and then we still have one more integral to go. 3 over x squared plus 2x plus 4.
So it'd be
How do we do that problem? Now we're ready to complete the square. We have to take x squared plus 2x plus 4. That's x squared plus 2x plus, what number should I add? A 1, which means I need to subtract a 1. So that's x plus 2 squared plus 3. All right, final answer. We're finally done this one, believe it or not.
X plus 1 squared.
X plus 1 squared, yes, thank you. All right, so this last one becomes integral of 3 over x plus 1 squared plus 3. And which of our many, many patterns does that now fit into? That's the arc tangent formula. So we're going to have 1 over a, which is 1 over the square root of 3. And then we still have that 3 on top. Arc tan of u, which is x plus 1 over a, square root of 3, plus c. You know it's a good problem when it took more than one piece of paper. Yeah, that's a good one. It took more than one for me. Do you think you'll see a problem like that on your test?
Yeah.
I would quit.
If that's the only one on the test.
And that would probably be a bad thing if it's the only one on the test, right? Because you get it wrong. So no, that's not a reasonable test question. I just wanted to show you how ugly it can get. Integration by partial fractions can be extremely difficult. There's a good example.
So you knew all that was going to happen?
I suspected it was going to happen because I knew how this was going to factor. And so I knew I was going to end up with a quadratic here where I knew I was going to have to complete the square. So I suspected it was going to happen. My only chance was maybe I would get really lucky and at where did I write it? Right here. Maybe I would get really lucky and U substitution would work. But it didn't. So I suspected I was going to have to complete the square on this one from the beginning. Yeah, it looks like a pretty easy problem, doesn't it? Doesn't look scary. Started small, and then it just exploded. All right, the last thing we have to talk about with partial fractions is what happens when you have a repeated linear term on bottom. And what I mean by a repeated linear is the integral of 5x minus 2 over 2 squared. All right, so first thing you need to do is recognize the difference in two types of problems. And these problems look very similar, but they're handled in different ways. This one would be a quadratic which doesn't factor, x squared minus 2. This one, on the other hand, is x minus 2 times x minus 2. It's a linear term, x minus 2, which shows up more than once. We call it a repeated root. Okay? So for this one, to handle it, you would need ax plus b over this quadratic one. The way you handle repeated linears is you're going to have 5x minus 2 over x minus 2 squared. You're going to have an a over x minus 2, and then you're just going to have a b over x minus 2 squared. Because it's still linear, it's still x minus 2, it's just showing up twice. Since it's linear on bottom, x minus 2, you still only need a number up on top.
We only have one x then.
What's that?
We don't have one x.
We're only going to have one good number x to plug in? Is that what you're talking about?
Oh. No.
Oh, well, let's see what happens.
I was thinking.
We do it the same way. We clear our fractions. 5x minus 2 equals a times x minus 2 plus b.
So we only have one x.
Yeah, we only have one x.
That's what I was
Yeah, you're right. All right, well, that's okay. If there's only one x, you get to pick your favorite number. X equals 2. When I plug 2 in, I have 10 minus 2, that's 8, equals b. I'm going to find a. I'm going to plug in the 8 for b. And what number am I going to plug in for x? Any number you like. Except you're not allowed to use the number 2 because you already used it. 1?
0.
I would have picked 0 myself, but if you want to use 1, you can. I'm going to use 0. So I'm going to plug in x equals 0, and I'm going to plug in 8 for b. So I get negative 2 equals negative 2a plus 8. So that's how you handle those. You just pick a favorite number that you like to plug in, and you plug it in, and you work it out. A equals 5. Okay, so we have the integral of 5 over x minus 2 plus b was 8. Oh, I can turn a b into an 8. See that? Over x minus 2 squared. That's 5. ln, absolute value of x minus 2, plus 8. How do you integrate that? What's the integral of 1 over x minus 2 squared?
16.
Nope.
It's just u squared 2 to the negative 2. It's going to be negative u, right?
So this is 1 over u squared du. I agree. So it's u to the negative 1 over negative 1. Yeah, all right. That one was an easy one to integrate. See, that's a Calc 1 problem. You get so used to doing all these hard ways, you forget about Calc 1, don't you? You forget about, that's a straight u substitution problem. All right, so this is x minus 2 to the negative 1 divided by negative 1 plus c. Questions on that? So in general, the repeated linear problems are typically quite a bit easier than the other problems that we did where you have quadratics that don't factor. Repeated linears usually aren't too bad. Questions on anything?